Welcome to all. My name Prema Sarvamanan from BSc 5th Sem Combination is easy. My topic is Coordination Chemistry 1 Classification of Ligands Werner's Theory of Coordination Compounds with reference to cobalt amine complexes Methods of Detection of Complex Formation. So we first know about coordination compounds. Coordination chemistry. Coordination chemistry is the study of compounds consisting of a central metal atom or ion bonded to a surrounding ions or molecules through coordinate covalent bonds. The combination of central metal atom or ion with the surrounding molecules or ions called ligands. Central metal atom or ion usually transition metal. Ligands are molecule that donates a pair of electron to the metal. Coordination number, it is the number of ligands donor atoms directly attached to the central metal atom. Coordination sphere, number of ligands do not donor atom directly attached to the central metal atom. Chelation, when a ligand from two or more bonds with the central metal ion. So what is ligand or defined ligands? It is or ions or molecules that can donate at least one lone pair of electrons to the central metal atom or ion to forms a coordination covalent bond and hence form a coordination complexes. So we discuss how to classify the ligands. Ligands are classified into so many types. Example, based on charge, based on density, based on binding mode, based on chelation, based on bridging nature. So first we discuss based on charge. Based on charge also have a three types: neutral ligands, anion ligands, and cation ligands. Neutral ligands are the ligands have no charge of ions. Example, H2O, NH3CO. And anion ligands, the ligands have negative charge of ions, Cl minus, OH minus. And cation ligands are the ligands have positive charge of ions, NO plus, NH2, NH3 plus, Na plus. And based on denticity, for example, monodentate, bidentate, polydentate, tetradentate, so many types. Monodentate, the donate one pair of electrons is known as monodentate ligand. Bidentate donate two pair of electrons from two donor atoms, ethylene diamine. Example, polydentate donate more than two pairs of electrons. The example of polydentate ligands is EDTA. And Werner's theory of coordination compound. The Werner's theory of coordination compounds is proposed by Alfred Werner in 1893. This theory explained the structure of coordination compound. So we discussed about postulates of Werner's theory. Two types of valences in metals. Primary valency ionizable corresponding to the oxidation state of metals satisfied by negative ions. Secondary valency corresponds to the coordination number of metals satisfied by ligands. The valencies are non-ionizable and represent inside the square brackets. 2. The number of secondary valencies is fixed for the metal atoms or ions gives its coordination number. Secondary valencies are directed in square responsible for the geometry of the complexes. Ionizable groups are written outside the coordination sphere while non-ionizable groups are ion inside. Complexes may be exhibit isomerism due to the different spherical arrangement of the ligands. Methods of detection of complex formation: conductivity measurement, cryoscopic osmotic pressure method, precipitate methods of AgNO3. Conclusion of the coordination chemistry. The coordination chemistry helps us understand how metal ions join with ligands to form a suitable complexes. Werner's theory clearly explained the structure and bonding in these compounds. By studying ligands and using different methods to detect complexes, we can learn about their properties, uses, and coordination compounds are very important in the chemistry, medicine, and industries. References of this coordination chemistry: a textbook of coordination chemistry by B.K. Sharma and Concise Inorganic Chemistry by J.D. Lai, and NCERT Chemistry textbook for 12th class, and Unit 9 is coordination chemistry. Thank you to all.